This is a complex fraction. It's a fraction within fractions. And what we can do to simplify this is to multiply everything through with the least common denominator. But before we can do that, let's find the inside denominators, the one that are inside the fractions. So inside here and inside here, where we have to exclude values. So we can exclude values for when b equals 5. That gives us 0 here, and of course this is just a 1. So we know that b equal to 5 must be excluded. That's going to become important when I multiply through by the least common denominator, which of course is b minus 5. This is a 1, so this can take any denominator. This one has a b minus 5, so this one needs a b minus 5 to get a common denominator there. So I'm just going to multiply everything by b minus 5 on top and bottom. And I can do that because I'm multiplying on top and bottom. That's the same thing as, right, if I multiply a statement by 3 over 3. Well, this is just 1, right? 3 divided by 3 is 1. And you can multiply anything by 1. It doesn't change the statement. Now, b minus 5, of course, does have a division by b minus 5, but we already had that, which is what this exclusion is supposed to, take care of. Okay, I can distribute that through here, and the same thing on the bottom here. That's going to give me, well, this and this are going to cancel. The same thing is true on the bottom. And then b minus 5 times 3, it's going to give me minus 3 times b minus 5. In the denominators, I have just 1 here and a 1 here, so I can just remove the denominators completely. Again, the b minus 5 is canceled, so it's just going to be 10, and then plus 6 times b minus 5. The denominators are now both 1, so I can just remove them. This is no longer a complex fraction, and I can simplify as I normally would. The first thing I'm going to do is I'm going to expand it, condense the numerator and denominator, and then I can factor and simplify it. Okay. So I have negative 5 minus 3b plus 15, 10 plus 6b minus 30. Okay, and combine like terms. On top I have plus 10. Minus 3b plus 10. And then on bottom I have 6b minus 20. Okay. On bottom, I can take out a 2. And on top, I can actually take out a negative. So this first one's negative. Let me do that. I take out a negative 1. That's going to leave me with 3b minus 10. And now you can see I have 3b minus 10 on both top and bottom that I can cancel. Before I can cancel that, let's make the exclusion. 3b minus 10. This equals 0. When I add 10, then divide by 3, I get 10 over 3. So b cannot equal that. I cancel those two things, and you can see my final statement is negative 1/2, where b cannot equal 5 or 10/3. So that's my full solution there. And even though b is not in the answer at all, b was in the initial statement. That's the reason why we have to keep this exclusion in there, even though b is no longer in the expression. It's important for graphing things like that. And that's my answer.